So, film screen processing. Quick overview, we're going to talk about image identification, right? And then we're going to talk about film screen processing. So, the ways that we can use a film screen method to identify the film, typically there's going to be a blocker on the screen itself that is made out of lead. It's going to prevent x-rays from exposing that part of the film while it's inside the screen. And we are going to be able to apply patient information to that area of blocked film. We're going to apply it with a light source. So in the dark room, when we take the film out of the screen, we're going to have like the patient's ID badge. We're going to put it inside of a little light source thing, and we're going to stamp that into a little light stamper, and it's going to expose then the patient's ID onto the film, directly onto the film, and then we'll send it through the processor, right? So when it processes, it'll come out with the patient's ID on it, right? Now, as you can imagine, there's lots of problems that come up with that. So anytime we're using film markers or what have you, some legal considerations that come with that is mislabeling. Like, how many times have you done a patient and the nurse comes up when you're done with the exam and say, hey, that's actually Gary Smith, not Jerry Smith, or whatever, and now you've got a mislabeled film, right? In the digital world, that's fine. You just go back and edit it in the packs, right? In the world of film, that was a massive pain in the butt, right? And so a lot of times when I was an extra tech working with film, you walked around with a Sharpie in your pocket because you'd be scratching things out or relabeling the film actually on the film, right? The incorrect marker was used. I cannot add that to the film. I'd have to write on the film, incorrect marker, exit out, and then write the correct marker use on it, right? So the other legal consideration with that is misfiling. Say just due to a clerical error or whatever, we've put Mr. Smith's film in Mrs. Smith's chart. How are you ever going to find that again, right? It was a massive nightmare. Normally with a digital world, again in the digital world, we can go back to track routing numbers and figure out what happened, right? Also, in terms of duplication and distribution, anytime we had to send the film out, we had to duplicate it. So we would have duplicating film and a little light box or something, and we would actually duplicate the film inside the darkroom and send it through the processor. You would lay the duplicating film over or underneath the other film, the actual x-ray, and then you would hold down the light box for a set amount of time and then process it. It would normally come out not looking as nice as the original, right? So people would they would complain about the duplication, right? So that was a legal consideration. We lost some information in duplicating it. A lot of that has been gotten rid of by using digital systems. Finally, we have to think about the archival quality. Just kind of file that term away back in the back of your brain. We'll talk about that because it relates to how actual processing works. So we have an automatic film processor. That's what pretty much everyone uses, is some form of automatic film processing. Very few people manually process. I'd be surprised if there's anyone left in the world who's manually processing x-rays. But it is possible to manually process. It just takes like 10 minutes to manually process an x-ray versus automatically we can do it in about 60 seconds to 90 seconds. So within it, there's going to be a series of tanks, and the film rolls through the tanks, right? And then it comes out the other side. And in those tanks, there's going to be a developer, a fixer, some kind of wash tank normally with water in it, and then a dryer, and then the film drops, right? So here's a graphic. Here's a graphic showing that, the film path down through the developer, then back out into the fixer, then back out, then into the wash tank, and then through the drying system, and then out of the processor, right? So let's look at that developer tank. The developer is going to change those silver ions that were exposed into metallic silver, right? And then it's going to provide the electrons to the sensitivity center of the crystal to change those silver ions into silver. So it's going to have something inside of it that allows the gelatin to become more kind of fluid, right? And then it's going to work its way into that emulsive area and complete the process that began in those crystals. So here we see how the developer is working. We have an unexposed film, then an exposed film. Everything moves to that sensitivity center, right? And then in the development process, the developer chemicals work down into that, remove the silver, and all that we're left with is this black spot, right? So it's going to show up as a density on our film. There's going to also, within the developer, be a reducing agent. So anytime an electron is given up by a chemical to neutralize a positive ion, the process is called reduction, right? And the silver ion, in this sense, is reduced to metallic silver. So it falls to the bottom of the tank. The developer agent responsible for this is just the reducing agent. And the really common one is hydroquinone. Okay? So, oxidation versus reduction, right? Oxidation is the absolute opposite of reduction. And a mnemonic to remember this with is Europe, right? Electrons are used by reduction, right? And electrons are produced by oxidation. And this comes from Bouchon. So electrons are going to be used up. We need something that has some free electrons in it in that developer tank to help with the reduction. Buffer. So this is going to just enhance the action of the developing agent by controlling like the pH, right? And common buffing agents are going to be sodium carbonate or sodium hydroxide, right? Anyone know the common term for sodium hydroxide? It's lye, right? It's it can cause burns. So let's talk about that. Sodium hydroxide is commonly called lye. And its alkali compounds are very caustic. They're very corrosive. They can cause skin burns, right? So use caution anytime you're messing around with the developer tank, right? Wear rubber gloves and never get it near your mouth or your eyes. You will know really quickly if you did, right? Wash your hands thoroughly if you're ever playing around with developer because it contains sodium hydroxide. Here's an example of the kind of burn that can be caused by sodium hydroxide. Okay, not fun. Fixer. So we've moved out of the developer tank into the fixer tank. After the development, film has to be treated so the image will not fade. Otherwise, it'll just continue to develop until it's a piece of charcoal, right? So in this sense, the image is fixed on the film by the fixer. It's going to contain an acidic acid and a fixer. So where the developer was more alkaline, now the fixer is going to be more acidic, right? And one of the things that we talk about from film photography is a stop bath. It stops the development, right? And the way it does that is it uses an activator to neutralize the pH of the emulsion, and it stops the developer action, right? So it neutralizes the pH that was excited by the developer, and then it stops that developer action. And the fixing agents responsible for this are these clearing agents, or we may call it just hypo, right? And it removes unexposed or underdeveloped silver halide, right? So it just takes it out of the mix. Nevertheless, we want to make sure that the fixer doesn't remain in the emulsion. If there's hyporetention is what we call the undesired or undesirable fixer retention in the emulsion. And what will happen is it will combine with the silver again to go back to create silver sulfide. Remember that stuff, the sensitivity specs, right? So if it remains in the film, the film's going to start to degenerate back to what it was, right? And it will appear as yellow-brown, right? And this silver sulfide stain is going to be one of the most common causes of poor archival quality. Remember what we were talking about with the medical legal considerations? If we leave this stuff sitting around, it was not properly developed, it's going to start to stain, right? We're going to start to lose some of our image to this hyporetention, okay? Then finally we have the washer and the dryer. I just put them both here together. And interestingly enough, the thing to know about the washer is the water temp is going to be about 3 degrees Celsius, 5 degrees Fahrenheit below the developer temp. So it's going to be kind of warm. And the washer temperature is going to help stabilize the developer temp because they're real close by each other, right? So if I had ice water in my washer, and I'm trying to keep my developer warm, it's going to be very difficult. But I'll use the water temperature to actually help influence how the developer, what its temperature is. And the main part of the washer is it's just going to reduce that hypo-retention. It's going to wash the fixer off of the film, right? And then finally we're going to have just a blow dryer system that blows warm air over both sides of the film, and then it drops out of the slot, right? Okay, let's talk about film storage, and then we'll talk real quickly about maintenance for these things, and we're pretty much done. So we want the area that we store our film to be cool and dry. And we want the temperature lower than about 68 degrees Fahrenheit. So ideally, film can even be refrigerated, right? Hardcore hospitals back in the day had like a refrigerator right outside the darkroom. Humidity and heat are going to reduce the contrast and increase the fog on the unexposed film. So heat itself could actually fog our film. Before I do any kind of x-ray or anything, I could already have fog on the film. We want the area to be dark. No light should be getting into the darkroom, right? Because the light can expose the emulsion prior to processing, right? Kind of goes without saying. A lot of times we want the film storage area to be lead lined. Now we don't need to line the entire darkroom with lead. We just need to line the area that we're storing the film. So our film storage container in there, the reason it's kind of clunky is it's surrounded in lead, because a lot of times the darkroom is going to be right next to your x-ray room, and x-ray film is much more sensitive to x-rays than people are, right? So we need even more lead around the area where the film is housed. And then it's going to have some kind of shelf life. Normally the box will tell you what the maximum shelf life is. It's usually about a year after purchase, right? Then in terms of maintenance, one of the first things, if we're working with a film processing system, one of the first things we should familiarize ourselves is what is the startup routine and the shutdown routine, right? How do we start the thing up? How do we shut it down? It needs to get up to temperature, right? Anytime we're developing something that's like a smaller piece of film, we should put it right up next to the tray so that when it feeds through the roller system, it activates the replenishment thing. If we put it right in the middle of the tray and send it through, it may not trigger the little analog trigger that says, hey, we need more developer now, we just developed a film. So put it right up next to the edge of the tray and then slide it into the processor. Film transport time through the processor shouldn't vary more than 2% from the time specified by the manufacturer. Why would that be? Did someone say something? Why would we not want the film to be taking a longer time to process than what the manufacturer said?
Because developed it. Yeah.
Right, it might get overdeveloped or underdeveloped. So it's important for us to be aware of what that transport time is. And then cleaning these tanks and transport systems should be part of routine. If we're in a busy department, it may need to be a monthly thing. If it's an area that's used less, it could be as far off as a year or half a year. And then most processor faults that lead to damp film are due to depletion of the developer, so it's just a matter of adding more chemicals, right? So we have to watch those chemical levels, make sure that there's an appropriate amount of developer and fixer in the tank. All right, and that's it. These are pictures from the World's Fair in 1890-something. They predicted that people would have balloon pants and that police officers would use x-rays to thwart criminals. The balloon pants, I'm really saddened to see that did not happen, especially the balloon pants for horses. Do you see the balloon pants for horses there?